Hello, fourth grade, and welcome to Unit 4, Week 4. We're going to start with our vocabulary words as usual. Your first word is the word specific. So when we're talking about something specific, we're talking about something in particular or the exact thing. We're not talking about, kittens in general. We're talking about my neighbor's new black and white kitten, right? So we give something specific. We're talking about the exact thing. Next, we have the word phases. Phases is a word that we've talked about before. And in this context, and for this week, when we're talking about phases, we're talking about it in terms of stages of the moon. So is it a full moon? Is it a crescent moon? Those are different phases. And there's a lot of other ones in between, of course. Next, we have the word sliver, not silver, even though that has the same letters, sliver. Sliver means like a really thin piece. A really thin pointed piece. So the crescent moon shape, right? It's a sliver shape, right? It's pointy and thin. You can just barely see it. If you cut off, if you have like pie and you cut just a sliver, like, right, you're taking a teeny tiny, really skinny piece. So keep that word in mind. Those are phases, and sliver are both going to be related to the moon, just like we were talking about. Our story last week was also related to the moon. This week, our story will be related to the moon as well. Next, we have the word series. Now, series means a group of things that are related that come one after another. So you guys have seen different series in a lot of things. You can see it like a book series, like the Magic Tree House, right? You have one book that comes after another, or you can have a movie series. If you've watched any movies where there's multiple movies that have, the same storyline, the same characters. So a series is a group of things that are related that come one after the other, like a TV series. And next we have the word rotates. So when something rotates, it's turning around on its axis, right? So it's got a point and it's spinning on that point. It rotates. So if you've ever seen someone spin a basketball on their finger, right? That basketball is rotating, and that axis point that it's rotating on is the person's finger. Or if you look at a globe, right, you can spin a globe around, and that globe is spinning in one place, and it's spinning on its axis. It's spinning at that one particular point. It's rotating around. Next, we have the word crescent. A crescent is a shape that is curved with a wide middle and narrow ends, right? So it's a little bit fatter in the middle, and it's pointy and skinny at the end. So the curved shape of a sliver is called a crescent moon. So when you take a sliver, like a thin little slice, and you curve it, right, you kind of make it like a half circle, that takes the shape of a crescent moon. Next, we have the word astronomer. Now, an astronomer is a person who studies the sky. So they're studying the planets, the moons, the stars, any other objects in outer space. That kind of scientist is called an astronomer. And our last word is the word telescope. And a telescope is a tool or an instrument that's used that has lenses on it, like magnifying glasses and mirrors, to make things that are far away look close. So if you've ever used a pair of binoculars, those work the same way a telescope does, right? You look through it so that something that's far away, you can see it closer than it actually is. All right, let's move into our spelling words for this week. Now, our spelling words for this week are focusing on diphthongs, and we've talked about these before. This is a vowel combination that makes a new sound, except for OW. OW is also considered a diphthong, even though W is not a vowel. But OI says oi, and OY also says oi. OU and OW both say ow, right? So we're taking those two letters to make a different sound. Like OI, like in the word oil, or OU, like in the word ouch. So your words for this week, I highlighted them to match the letter combinations that we have on top. So we only have two sounds that we're working with. They're just, each one is spelled two different ways. So that oi sound is spelled OI or OY, and that ow sound is spelled OU or OW. So the words that we have this week are the words noises, voices, rejoice, annoy, destroy, voyage, mound, south, pound, pound, pouch, thousand, wound, grouch, cowboy, gown, frown, howling, flower, tower, crook, zoom, group, drought, and downtown. So when you're doing your 3 times each, please be careful with the spelling, because even though they make the same sound, they're spelled 2 different ways. So be very careful when you're doing your 3 times each to make sure that you're writing your words very carefully and paying attention to those diphthong combinations. Now let's get into our language arts and grammar for this week. So first we're going to talk about Greek and Latin roots. And we've done this before with other Greek and Latin roots. The ones we're going to focus on today are the Greek root graph, the Latin root spec, the Greek root phone, and the Latin root aqua. So the English language and several other languages are made up of these root words, and a lot of those root words go back to the Greek and Latin languages. Now, the root graph means to write. So if you get someone's autograph, that person is writing their own name, right? Auto is another root that we've talked about in the past. Auto means self. So an autograph is someone writing their own name. A pictograph, you guys have done this in math, is a graph. You're writing down the information or you're showing the information using pictures. A digraph is when we're writing 2 letters that make a single sound like SH or CH. A biography is the story about someone's life. Next, we have the Latin root spec, and spec means to look. This is where we get words like spectator. A spectator is like someone who's in the audience, who's watching something. Anyone who's watching is called spectator. Spectacles. Spectacles is another way to say glasses, like the glasses you wear so that you can see more clearly. You look through those, right? An inspector is someone who looks at things when they're trying to solve a mystery. The root phone means sound, and that's where we get words like telephone, which is, a device that we use, a piece of technology we use to communicate. Homophones are words that have the same sound, even though they're spelled differently. And phonology is the study of sound, of different letter sounds. The last one we're going to talk about is aqua, and aqua means water. This is something that you guys are familiar. If you've ever been to the aquarium or you've done any aquatic sports like jet skiing or water, like what do they call it? When you're sailing, those like water skis, or parasailing, or when you're kind of attached to a motorboat and you're kind of on a parachute. Or if we're talking about something that's subaquatic, that's something that's underwater. The next part we're going to go over are possessive nouns and pronouns. So possessive nouns and possessive pronouns, to be more specific. Now we know that a noun is any person, place, or thing, and a pronoun takes the place of one or more noun. So this week we're going to focus on possessive nouns and possessive pronouns. A personal pronoun refers to a person, place, or thing such as I, you, he, she, it, they, we, us, them, him, or her. And it takes the place of the name of that noun, right? So instead of saying, we went to Miss Zaina's class, you can say we went to her class. And a possessive pronoun takes the place of a possessive noun and doesn't have an apostrophe or an S. So possessive pronoun is going to be his, her, my, your, our, or their. And it's usually found immediately before another noun, right? So possessive pronouns, you usually find them right before the thing that they're showing possession of or they're showing ownership of. So this is his apple. So his is the possessive pronoun, and apple is the thing that he possesses. It's what he owns, right? This is his apple. Where is her bag? Can you help me find my book? Please take out your pencil. This is our puppy. We are going to their house today. So you can see that that possessive pronoun is found immediately before the noun that it's possessing, that it's holding on to. Now we also have something else called a standalone possessive pronoun. And this is not found right before the noun. It's usually towards the end of a sentence, and it has an S on the end of it. So instead of words like her or my or your or our or their, it's going to become yours, hers, theirs, ours, and mine instead of my. Now, its and his can be used as regular possessive pronouns or as standalone. They don't change their form. You just, from your context clues in the sentence, you're able to figure out, is it a possessive pronoun? Does a noun come immediately after it? Or is it a standalone possessive pronoun? There's no noun immediately after it. So some example sentences can be, this seat is yours, right? There's no noun that comes after it. We know what we're talking about. We're talking about the seat. The backpack is hers. The blue car is theirs. The striped umbrellas are ours. That pencil is his. That lunchbox is mine. So we looked at possessive pronouns that come right before a noun and standalone possessive pronouns. Now let's talk about just possessive nouns. So not in pronoun form, in the regular noun form. So we have singular possessive. That means one thing owns something else, or we have plural possessive, where it's a group that owns something. Now, singular possessive shows ownership, and it has an apostrophe S after the noun to show that it's possessive. So the dog's toy squirrel was in the yard. So we're talking about a toy squirrel that belongs to that one dog. If I say, my sister's friend lives next door, I'm talking about one sister and her friend that lives next door. My mom's cooking is the best. So I'm talking about the cooking of my mom. I've only got one mom. Or my cat's favorite thing to do is nap. So I'm talking about the favorite thing or favorite hobby of my one cat. Now, plural possessives have an apostrophe after the S if it's a regular plural, or an apostrophe plus S if it's an irregular plural. Now, we've talked about regular and irregular. Regular plurals, how you just throw an S on the end of it, like cat becomes cats, dog becomes dogs. Irregular plural is like man becomes men, or mouse becomes mice, or tooth becomes teeth. Those are irregular. You don't just throw an S on the end of it. So for a regular plural to become a possessive, you just put an apostrophe after that S because the S is already there. So you throw an apostrophe on right after it. So the rabbit's cages were empty. So you see that the word that comes right after it is also plural. That gives you a hint that tells you that your possessive noun in that sentence is a plural possessive. Because if it was one rabbit, it would say the rabbit's cage was empty. So cages and were are both your clue words that tell you that we're talking about a plural possessive. So you know that it has an S and then an apostrophe after it. The dragon's caves were empty at dawn. So again, caves is plural, and were is a word that we use with multiples or with plurals, not with singular. With singular subjects, we say was. When the subject of the sentence is plural, we say were. The aliens' agents were looking for Stitch. So if you've seen Lilo and Stitch, you know what I'm referring to. So aliens, we're talking about a group of aliens. So the apostrophe comes after that S. And the agents of those aliens, right? The agents that belong to the aliens were looking for Stitch. And my last example of a regular plural possessive is the fireflies' lights were glowing brightly. So I'm talking about multiple fireflies. You can see that this is in plural form. Since we have the S at the end, it's already there, so we add an apostrophe after it. Now for irregular plural possessives, these can be ones that are irregular or collective. So child becomes children when it's plural. The children's playground had a swing and a merry-go-round. So children apostrophe S, because the word children doesn't have an S already at the end of it. So we still add the apostrophe S the same way we do as if it were singular. The geese's honking was irritating. The men's voices echoed into the hallway. The mice's paws scratched across the attic floor. So all of these, because they're an irregular plural, it's a plural word that doesn't end in an S. We add the apostrophe S at the end of it. Let's go ahead and take a look at our literature anthology book. And we're going to read another expository text. And this one is titled, Why Does the Moon Change Its Shape?
Genre: Expository text. Why Does the Moon Change Shape? By Melissa Stewart. Essential question: How do you explain what you see in the sky? Read about the different phases of the moon. The mysterious moon. For as long as people have lived on Earth, they have asked questions about the bright lights that fill the nighttime sky. What causes them? How far away are they? Why do they move from night to night? For thousands of years, the moon has been the most mysterious nighttime object of all. It is the largest object in the night sky, and it is the brightest. What amazed ancient people the most is how the moon's shape is constantly changing. Sometimes it looks like a full bright circle. Other times, only a tiny sliver appears. It did not take ancient people long to realize that the moon's changes, or phases, follow a regular pattern. The moon's phases repeat themselves every 29 or 30 days. If you watch the moon every night for about a month, you can see all its phases. At the beginning of each cycle, people on Earth cannot see the moon at all. After a few days, a tiny sliver of light appears in the nighttime sky. Each night, the moon looks a little larger. After a week, it looks like half of a circle. And about a week after that, a full round disk brightens the night sky. But then the moon starts to shrink. Each night, it gets a bit smaller. After about a week, the moon looks like half of a circle. And a week after that, the moon disappears completely. But a few days later, a tiny sliver of light returns. This 600-year-old drawing shows two European astronomers studying the moon and recording their observations in a notebook. Stop and check. Ask and answer questions. Why were ancient people amazed by the moon? Go back to the text to find the answer. Our place in space. Earth is one of 8 planets in our solar system. The other planets are Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. All 8 planets orbit or move around a star called the Sun. A year is the amount of time it takes a planet to circle the Sun once. Earth completes the trip in about 365 days. So an Earth year is 365 days long. That is the amount of time between your last birthday and your next birthday. Mercury is the closest planet to the Sun. It makes one full orbit in just 88 days, so a year on Mercury is much shorter than a year on Earth. Neptune is the farthest planet from the Sun. It takes Neptune 165 Earth years to circle the Sun. That is a really long time to wait between birthdays. Each planet in our solar system follows a specific path as it orbits the Sun. Planets are not the only objects that orbit the Sun. Thousands of smaller rocky chunks called asteroids and dwarf planets do too. Most asteroids follow paths located between Mars and Jupiter. Dwarf planets, such as Pluto, are larger than asteroids. Their orbits are located beyond Neptune. Comets are small icy objects that orbit the Sun. Their orbital paths around the Sun are long and thin, like a cucumber. Planets, asteroids, dwarf planets, and comets do not fly off into space because the Sun's gravity is always tugging on these smaller objects. Their forward movement is perfectly balanced with the pull of the Sun's gravity. Asteroids are small rocky objects that orbit the Sun. The Moon in motion. The Sun is not the only object in our solar system with enough gravitational pull to attract smaller bodies. 6 planets, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, have smaller objects orbiting them. So do a few asteroids and dwarf planets. These smaller objects are moons. Scientists have identified at least 60 moons circling Jupiter. Saturn probably has even more. But Mars has just 2 moons, and Earth has only 1. In this image of Earth and the Moon, you can see part of the far side of the Moon, the half of the Moon that never faces Earth. Earth's moon is closer to Earth than any other object in space. Still, it took Apollo astronauts traveling at rocket speed about 4 days to reach the moon in the late 1960s and early 1970s. The moon is about 238,860 miles, 384,400 kilometers, from Earth. That is almost 100 times farther than the distance between New York, New York, and Los Angeles, California. It takes the moon about 27 days to complete one full orbit around Earth. That means it circles our planet about 12 times each year. As the moon orbits Earth, it also rotates or spins like a top. Earth rotates too. Our planet takes about 24 hours, or 1 full day, to complete one rotation. The moon spins much more slowly. It rotates just once during each 27-day orbit. As Earth spins, different areas of the planet face the Sun. It is daytime in the places that are facing the Sun. That is why days are bright and sunny. It is nighttime on the part of the Earth facing away from the Sun. That is why it is dark at night. The amount of time it takes the moon to rotate is the same as the time the moon takes to orbit Earth, so people on Earth always see the same side of the moon. Scientists call the side we see the near side. When the near side of the moon is lit up by the Sun, we see a full, bright circle. When the far side of the moon is fully lit up by the Sun, we cannot see the moon at all. A total of 6 Apollo spacecraft carried people to the moon. The astronauts returned with photos, rock samples, and amazing stories of what they saw as they cruised around in lunar rovers. This X-ray image of the Sun shows some of the fiery gases it sends out into space. Let there be light. The Sun is a star, a giant ball of boiling gases. The temperature at the center of the sun is 27 million degrees Fahrenheit, 15 million degrees Celsius. The gases inside the sun are so hot that it glows. The sun is not the biggest star in the universe, but it looks the brightest in the sky to us because it is the closest. During some parts of the year, we can see Venus, Mars, Jupiter, and Saturn as bright, steadily shining dots of light in the night sky. But these planets do not produce their own light. The light we see when we look at them comes from the sun. As the sun's rays hit a planet, some of the light bounces off the planet's surfaces and travels back into space. When some of that reflected light reaches our eyes, the planet seems to glow. The moon reflects the sun's light too. We know from astronauts and space vehicles visiting the moon that it is made of solid rock. There is no source of light on the moon. We can only see the moon when the sun is shining on it, and then that light is reflected off the moon's surface and into our eyes. The moon is much smaller than Venus, Mars, Jupiter, and Saturn, but it looks bigger and brighter to us because it is much closer to Earth than those planets are. Stop and check. Ask and answer questions. How are we able to see planets and moons when they do not produce their own light? Go back to the text to find the answer. Why does the moon change shape? During any 29 or 30-day period, the moon's appearance seems to gradually change and then return to its original shape. But the moon is not really changing at all. What you are seeing is the moon being lit up by the sun's rays in different ways on different days. What causes these differences? Changes in the positions of the moon and Earth. The moon's light comes from the sun. It looks different to us on different days because the moon and Earth are always moving. In the first phase of the moon, called the new moon, the giant ball of rock is not visible on Earth at all. That is because the moon is in between the sun and Earth. The far side of the moon is being lit up by the sun, but the near side is not. As the moon orbits our planet, more and more of the near side is lit up by the sun's rays. After a few days, you can see a C-shaped sliver called a crescent moon. Some people think this phase of the moon is shaped like a crescent roll. Close to 1 week after you see the new moon, the sun lights up about half of the near side of the moon. This phase is called the first quarter moon, because the moon is now 1/4, or 25%, of the way through its full cycle. A few days later, the moon will have traveled far enough in its orbit for you to see a shape that has curved humps on both sides. This phase is called the gibbous moon, because gibbous is the Latin word for humped. Around 2 weeks after you see the new moon, the sun shines directly on the near side of the moon. The entire full moon is lit up. This crescent moon appeared 5 days after the new moon. As the moon continues to orbit around Earth, the moon begins to disappear. After a few days, you will see another gibbous moon in the sky. Close to 3 weeks after you saw the new moon, the sun lights up only about half of the near side of the moon. This phase is called the last quarter moon, because the moon is now just 1/4, or 25%, away from completing its full cycle. A few days later, all but a tiny sliver of the crescent moon will have disappeared. Most of the sun's rays are now falling on the far side of the moon. In just a few more days, the moon will disappear completely. The moon has returned to its original position in its orbital path. The far side of the moon is fully lit up by the sun, but the near side is in complete darkness. The moon has cycled through its phases for years, and it will continue to do so as long as our planet and its mysterious moon exist. This stunning full moon appeared over gigantic rock formations called buttes in Monument Valley, which is located in Utah and Arizona. This last quarter moon appeared about 3 weeks after the new moon.
All right, that takes us to the end of our first story. Our next one is a Greek part. It comes from mythology. I believe it comes from Greek mythology, and it's titled "How It Came to Be."
Genre: myth. Compare texts. Read 2 myths that seek to explain what people see in the sky. How it came to be. The following 2 myths originated thousands of years ago, during a time when people did not yet enjoy all the benefits of modern science. Astronomers with telescopes did not exist to answer questions about the universe. Instead, people told stories to explain what they saw in the sky above. Why the sun travels across the sky. A retelling of a Greek myth. Helios, the Titan god of the sun, brings light to the earth. He dwells in a golden palace in the east on the river Okeanos. Each morning, Helios follows his sister Eos, the goddess of the dawn, across the sky. He drives a shining chariot, drawn by 4 noble steeds, upward through the clouds. The chariot moves higher as rays of brilliant light pour forth from Helios's crown. Slowly the steeds climb with a single purpose. Hours later, they finally reach the highest point of the sky. Pausing only briefly to rest, Helios then begins the long and difficult journey downward. He travels toward his western palace. The path is steep and treacherous. Helios must master his steeds so that they do not fall headlong into the earth. If his chariot happened to drop too low in the sky, it would scorch the land and all its people. After many hours, Helios arrives safely at the gates of his western palace. As darkness overtakes the earth, he begins his journey back to the east. Instead of traveling across the sky, he and his steeds sail in a golden boat from the gods along the river Okeanos. He returns to his eastern palace to repeat his journey across the sky. Helios will continue to take this journey for as long as there are days and nights. His shining light warms us each day as the sun travels tirelessly across the sky. Why there is thunder and lightning. A retelling of a Norse myth. Thor, the mighty Norse god of thunder and lightning, is both large and powerful. With his long hair, flowing beard, and quick temper, he often intimidates other gods. Despite his fierce appearance, he is considerably popular. Thor is admired for his ability to protect both gods and humans against evil. Among the Norse gods, he is the strongest of all. Thor lives with other warrior gods in Asgard, one of the 9 worlds located at the highest level of the Norse universe. Odin, Thor's father, rules Asgard. Odin is a great warrior who is often associated with a quest for wisdom. Still, he is not nearly as popular as his son. 3 treasures help Thor emerge victorious time and time again. One is a belt that increases his strength. Another is a pair of iron-clad gloves. The 3rd treasure is his greatest, a mighty war hammer. This hammer helps Thor protect Asgard from all enemies. When Thor throws his hammer, it magically returns to him like a boomerang. During thunderstorms, Thor is said to be riding through the heavens in his mighty chariot, pulled by a pair of enormous goats. The sound of the chariot wheels creates a thunderous rumbling that shakes the world. Lightning flashes across the sky whenever Thor throws his magical hammer. The experience of thunder and lightning can be frightening and oddly reassuring at the same time. It reminds us that Thor is a fierce and all-powerful warrior, but one who will always be able to protect us from harm. Make connections. How do the myths of Helios and Thor help to explain what people see in the sky? Compare and contrast the myths. Contrast how ancient people understood their world and how modern people understand the world today. Explain using examples from the selections.
All right, that takes us to the end of our stories in our literature anthology. Let's take a look at our reading and writing workshop. We're going to be reading a text called The Light Show.
The Light Show. For centuries, people have come up with stories to explain what they see in the night sky. This photo shows the Northern Lights, which you will soon read more about. The Inuit who lived on the lower Yukon River believed the Northern Lights were actually the spirits of animals dancing in the sky. If you had lived 500 years ago, how would you have explained the Northern Lights? What have you observed in the sky at night? Talk about it. Write words that name or describe things that appear in the night sky. Then talk to a partner about stars, planets, comets, and eclipses. Genre: expository text. Wonders of the night sky. Essential question: how do you explain what you see in the sky? Read about what causes some of the sights you see in the sky. As Earth rotates on its axis, day becomes night. Suddenly, a gallery of lights is revealed. You may see a beautiful crescent moon. Maybe you'll see one of the other phases of the moon. You may even see a series of lights spread across the sky like colored ribbons. For thousands of years, people have loved looking at the night sky. For almost as long, scientists have been trying to explain what they see. Aurora Borealis. Every few years, an amazing light show is seen in the skies near the North Pole. It is known as the Northern Lights, or the Aurora Borealis. Aurora Borealis. Brilliant bands of green, yellow, red, and blue lights appear in the sky. People used to believe the lights were caused by sunlight reflecting off polar ice caps. The theory was that when the light bounced back from the caps, it created patterns in the sky. In fact, the lights happen because of magnetic attraction. The sun constantly gives off a stream of electrically charged particles in every direction. These nearly invisible pieces of matter join into a stream called a solar wind. As Earth orbits the sun, solar winds reach Earth's magnetic field. As a result, electric charges occur that are sometimes strong enough to be seen from Earth. These electric charges cause the colorful bands of light in the sky. The Aurora Borealis above Hammerfest, Norway. Comets. Another kind of light you might see move across the night sky is a comet. The word comet comes from a Greek word that means wearing long hair. It came from the Greek philosopher Aristotle, who thought that comets looked like stars with hair. Long ago, people feared these mysterious streaks because they believed that they might bring war or sickness to Earth. Today, comets are less scary and mysterious because we know that they are a mixture of rock, dust, ice, and frozen gases that orbit the sun. Comets move around the sun in an oval-shaped orbit. When a comet comes closer to the sun, the result is that a tail of gas and dust is pushed out behind the comet. This long tail is what people see from Earth. Scientists think comets are some of the oldest objects in space. They can track specific comets and predict when they can be seen from Earth again. Nucleus, coma, meteors. Have you ever looked up at the sky and seen a shooting star? Those streaks of light are not really stars at all. What we call shooting stars are usually meteors. Meteors are another name for the rocky debris and fragments that enter Earth's atmosphere. Sometimes Earth passes through an area in space with a lot of debris. This is when a meteor shower occurs. You may see hundreds of shooting stars on the night of a meteor shower. These days, an astronomer or anyone with a portable telescope can raise new questions about space. What do you see when you look up at the night sky? Whether you look at a sliver of the moon or a fantastic light show, you are bound to see something amazing. The Perseid meteor shower. Make connections. Talk about what causes some of the sights in the night sky. What do you wonder about when you look up at the night sky?
All right, that takes us to the end of our readings for this week. Next, we're going to talk about our comprehension strategy and skill. Now, our strategy, again, is going to be about asking and answering questions. So as you come across new information in a text, a good strategy to use to help you understand it well is to ask questions about it. That way you can go back and revisit the information, think about it a little bit more deeply, so you get a good understanding of it. The comprehension skill we'll talk about after that is cause and effect, and this is one we've talked about before as well. A cause is the main action or thing that happened, and the effect is what happened because of it. What did it lead up to? So let's go ahead and listen.
Ask and answer questions. When you read an informational text, you usually come across new facts and ideas. Asking questions and reading to find the answer can help you understand new information. As you read Wonders of the Night Sky, ask and answer questions about the text. Find text evidence. When you first read Wonders of the Night Sky, you may have asked yourself what causes the northern lights. Aurora Borealis. Every few years, an amazing light show is seen in the skies near the North Pole. It is known as the Northern Lights, or the Aurora Borealis. Aurora Borealis. Brilliant bands of green, yellow, red, and blue lights appear in the sky. People used to believe the lights were caused by sunlight reflecting off polar ice caps. The theory was that when the light bounced back from the caps, it created patterns in the sky. In fact, the lights happen because of magnetic attraction. The sun constantly gives off a stream of electrically charged particles in every direction. These nearly invisible pieces of matter join into a stream called a solar wind. When I read this section of the text, I found the answer to my question. The northern lights are caused by the sun giving off electrically charged particles. Cause and effect. Text structure is the way that authors organize information in a selection. Cause and effect is one kind of text structure. A cause is why something happens. An effect is what happens. Find text evidence. When I reread the Aurora Borealis section on page 281 of Wonders of the Night Sky, I can look for causes and their effects. Signal words such as cause, because, and as a result tell me that a cause and effect relationship is being explained. Graphic organizer. Cause, effect. Cause, sun gives off electrically charged particles. Effect, particles join into a solar wind. Cause, solar winds reach Earth's magnetic fields. Effect, as a result, electric charges are seen from Earth.
All right, next let's review our genre for this week. We were talking about expository text, so texts that give us information and facts, texts that have text features such as diagrams, captions, bold-faced words, headings, all sorts of things that we find in a text that is teaching us something.
Expository text. Wonders of the Night Sky is an expository text. Expository text explains facts and information about a topic. Includes text features. Find text evidence. I know Wonders of the Night Sky is an expository text because it gives many facts about the night sky and includes text features. It has boldface words, pronunciations of unfamiliar words, and a diagram. Text features. Diagrams. Diagrams show the parts of something. Boldface words. Boldface words show keywords in the text. Pronunciations. Pronunciations show how to sound out unfamiliar words. Context clues. As you read the information in Wonders of the Night Sky, you may come across words that you don't know. To figure out the meaning of an unfamiliar word, check the words or phrases near it carefully for clues. Find text evidence. When I read the third paragraph on page 281 of Wonders of the Night Sky, the phrase, "light bounced back," helps me figure out what reflecting means. People used to believe the lights were caused by sunlight reflecting off polar ice caps. The theory was that when the light bounced back from the caps, it created patterns in the sky.
All right, that takes us through to the end of our notes for this week. If you have any questions, let me know. Otherwise, I hope you have an amazing day. Take care, fourth grade. Bye-bye.